All right, so now what I'm going to do is just going to bring this in, and I'm going to rewrite it as n to the 1/2 again. So that's going to be, again, I'm multiplying, right? So I'm distributing. So then when you multiply, you add the powers. So this is going to be n to the 5/2 plus 2n to the 2/2, 3/2. And on the bottom, we have just 5 times all of this. Okay. Now, believe it or not, if you use L'Hopital's rule, because technically you have an infinity over infinity, right? It's going to be a pretty bad mess. Well, the top won't be too bad. The bottom's going to be pretty bad because you have, you have to use the product rule. Derivative of the inside times the derivative of the outside. It gets kind of messy. Now, you could do that. And it'll take you a while. I actually did it, and it took me about an extra 10 minutes to do it. So I'm going to show you guys a nice little slick way. Is, well, what if I just factor out from the top everything we have? So if I factor out a 5, and so I'll just show you 5 n to the 5/2 power. So if I just factor this out, well, this becomes 5. And over here, I'm taking more than I need out. This is just going to be 2 n to the negative 1 power. Okay. Now, the same thing on the bottom. If I factor out a n to the 5th from here, I now have 9 over n to the 5th, and this becomes 1. Now, if you're wondering how in the world is that, because if I distribute this, those cancel, right? So you just factor out a portion. Okay. And now if I refactor this out of here, so -1 plus 1. Again, I don't have that, so this is going to be a 5 there. Okay, notice these cancel, which is a good thing. Okay. So now there's another nice rule we talked about last couple sections, is you could take the limit of the top and the bottom individually and see what we get out. So if I just look at the top, if I take the limit as n goes to infinity, notice this goes to 0. So on the top, we have 5 plus 0, because this goes there. Now if I do the same thing on the bottom, if I take the limit of this portion, this also will go to 0. And we just have 1 right there. Oh, this is a 5 value, sorry. So now, just evaluate that. That's just going to be 5 over 5 times the square root of 1, which is 1. And 5 over 5 is just 1, which again is greater than 0. Uh-oh. That's not good. Right? You're wondering, well, why is it not good? Because this shows it's actually a value. So if you go back to the comparison test, oh, we're actually good. Anyway, you have a c-value greater than 0, and it's a finite number. So therefore, you got a finite number. So therefore, because our original diverged, therefore, if our n value, b sub n value diverges, so therefore this also diverges. So after all of this mess, we find out that this diverges. Okay. There we go. So I would have been in trouble if we actually got like infinity. Then it wouldn't work at all because it has to be an actual number or finite number, right, according to our definition. Either way, it has to be a finite number that's strictly greater than 0. So if we got 0 exactly, tough of luck. Either you find a different series or try to prove it actually converges somehow, okay, when it comes to it.